When we talk about statistic as the science of collecting data, we refer to the collection of methods that we use to collect a sample from a population. There are many types of sampling out there, but in this video, I'm going to concentrate my discussion on simple random sampling, stratified sampling, cluster sampling, systematic sampling, and convenient sampling. When we talk about sampling, we define that as techniques of selecting individual members or a subset of the population to make statistical inferences from them and estimate characteristics of the whole population. So when we decide to sample some subset out of a population, we need to be very careful about the way we conduct that collection of individuals, because we want that sample to represent the whole population. So we start our discussion with what is simple random sampling. It's a technique where every item in the population has an even chance and likelihood of being selected. Think about having every single individual of a population in a bucket. You put them all in there, and without looking at it, you choose a subset of them. You are not having any preference on any of the individuals inside of that bucket because you're not seeing them. So then every single individual in that bucket has the same chance of being selected when you pick them out from the bucket. It is a fundamental sampling method that can easily be accompanied of a more complex sampling method. And you'll see that because for the other ones, for the stratified sampling, for the cluster sampling, we need to use a simple random sampling, and within them, we refer to this as SRS. So if you see those three letters together, as we move forward in the video, please know that that's what we are meant to talking about, simple random sampling. So the main attribute of this sampling method is that every sample has the same probability of being chosen. When we talk about systematic, we need to create a system. That's where the name came from. We start by randomly selecting a starting point in a list of names. How do we select that starting point? There is a lot of random number generators. So we generate randomly a number from, let's say, 0 to 9. And that's going to be our seed. That's going to be the first number or the first individual that we choose out from our population. Like, let's just say, for example, with this figure that we have in here, we randomly choose individual number 2 to be our initial point, okay? Then we are going to take every nth piece of data. Sorry about that. We're going to take every nth piece of data from a list of the population. So let's just say that the nth piece that we are going to select is the third piece. So then we're going to move from our initial individual, and we are going to count 1, 2, and 3, and the third person in the list gets selected to the sample. Then so we choose number 5. Then we go again, 1, 2, and 3. And this third person again gets selected to be a member of the sample. Then from here, we do it again, 1, 2, and 3. So individual number 11 is the one chosen to be part of the sample. We do this as many times as we need to collect the sample of the size that we have decided to collect. It can be 10, it can be 20, it can be whatever it is, the size that you need. How we decide on a sample size, we're going to discuss that in a further a long video. So that's systematic. You create a system to randomly select individuals out from your population. What's the system? You choose the first number randomly, and then you decide on after how many you will choose, like that after every nth piece of data. And that's going to depend on the size of your population, how many individuals you want to choose from your sample. In this case, our first individual is 2, and then we are taking every third individual. So we start at 2, plus 3, that's 5, plus 3, that's 8, plus 3, that's 11. So 2, 5, 8, and 11 are going to be the members of my sample. Next one is stratified. So here, what we do is we have a big population. We divide that population into groups, and the grouping depends on the characteristic that we want to study. From there, once we have our groups, we go to each of our groups and take samples randomly. So we use that simple random sample, and within each of our groups, and we choose a sample out of there. All right, so let's say that we have this population, and within that population, we divide it into 3 big groups. All right, so we have 3 big groups. What we are going to do is we are going to take a simple random sample from group number 1. We are going to take a simple random sample for group number 2, and we are going to take a simple random sample for group number 3. All of the individuals that were chosen to be part of the sample from group 1, 2, and 3 are going to be my sample. All right. Something that we can take into account when we talk about stratified is that sometimes we take proportionate samples from each group, and this is just to balance it out. So if for any reason the groups within the population doesn't need to have the same size. So if you have groups within your population and the sizes of their groups are very, very, very different, for you to kind of account for that and not having or not ignore the group that it's smaller into your sample, then you take a proportion group or a proportion sample out of every one of your groups, so that each group is pretty much represented in the same way into the sample. When we move on into clusters, you are going to divide the population into groups, right? Now, for the cluster, you are going to randomly select some of the groups. Then once you select randomly the groups that you are going to use, the entire population within those groups is used for your sample. So let's go back and talk about, let's just have a population, and we decide that we are going to have 4 groups. All right, so we have our population divided into 4 groups. We randomly choose the groups that are going to be part of my sample. So let's just say that I put this into a random generator, a random number generator, and I got group number 1 and I got group number 4. So I randomly choose group number 1 and group number 4 to be part of my sample. Then what do? I go to group number 1 and I choose every single individual inside that group. Then I go to group number 4 and I choose every single individual inside of group number 4 to be part of my sample. So the sample will be everyone in group number 1 and everyone in group number 4. All right. How are they different? Stratified and cluster sampling. So if you can see in this figure in here, we have like a red group and a blue group. For the stratified, I choose individuals randomly from the red group, and individuals randomly from the blue group, right? When we talk about cluster, I'm going to divide my population into groups. So in this case, I have 1, 2, 3, 4, 5 groups. All right. And if I just leave those numbers 1, 2, 3, 4, and 5, I randomly choose group number 2 and group number 4 to be part of my sample, and then every individual in group number 2 and every individual in group number 4 are selected to be part of my sample. All right, stratify, all of the people in the red group was not selected to be part of the sample. We randomly chose these 2 from the red group to be part of the sample. And for the blue one, we randomly choose these 3 individuals to be part of my sample. On the contrary, in here, once I choose the group, everyone inside of that group goes to the sample. All right, so last one, let's talk about convenience sampling. When we talk about convenience sampling, this is the one that is not random, right? When you do convenience sampling, you are involving a population that is really accessible and available to you. So if I'm just making an example, you want to understand or kind of research behavior of people using Facebook, and instead of choosing a random sample, just ask your friends how they use Facebook on a daily basis. That sample is a very convenient sample. You are choosing that because it's accessible for you, but it doesn't mean that the friends that you choose to ask the question represents the entire population of Facebook users, to make an example. All right, so that is what convenience means. Let's see if we understood this. Example number 1. In order to study the true sizes of people in his town, Billy samples the population by dividing the residents by age and randomly selecting a proportionate number of residents from each age group. Which type of sampling is used? All right, so we have our options: systematic, cluster, stratified, convenience. So first, systematic, it cannot be. Remember, systematic, you need that system. You need to know who is the first one, and then how, what is your nth, every nth people that you're choosing from your sample. Convenience, it is not convenience. It he is using the population and he's dividing the residents by groups. So then the convenience is just very accessible to you. So this one is going to be either cluster or stratified, right? So here, Billy samples the population by his dividing the residents by age, right? So he is dividing his population into groups. The groups are decided by the age of the individual. And then he is randomly selecting a proportionate number of residents from each age group. So when do we choose individuals from each group? So if we go back, from each group means that we choose some from here, some from here. So that's going to be stratified. So go back here. So what Billy is doing here to study the true sizes of the people in his town, it is stratified. He's taking all of the residents in the town, making groups, using age to determine in which group an individual belongs to. And then from there, he's selecting residents from each of the group age. So again, that is stratified. Example number 2, to study the mean blood pressure of all people in her state, Christine samples the population by dividing the residents by towns and randomly selecting 9 of the towns. She then collects data from all the residents in the selected towns. Which type of sampling is this? Systematic cluster, stratified, or convenience again. So I'm going to just pause here for a couple of seconds and let you think about it. Make your decision which one do you think it is. And then I'll tell you what it is. All right, so we have kind of the same situation. We have Christine that wants to study the mean blood pressure of the people in her state. So people in her state is the population. She's going to divide that by town. So town 1, town 2, 3, 4, 5, I don't know how many she has. But then it says that she randomly select 9 of the towns. And then all of the residents in each of the towns is selected to complete whatever it is that she's doing. Maybe it's a survey. So then if you use all of the people within a group, and the groups are the ones that are chosen randomly, that is cluster, right? Remember that in a cluster, you choose your groups randomly, and then everyone inside those groups gets selected. In stratified, you divide your population and you take individuals randomly from each group. All right. Example number 3. Ruby is studying the mean waist size of all students attending her college. She collects data from the 25 students in her statistic class. Which type of sampling is used? So let's just think about it again. We have a population which has all of the students attending her college. Is Ruby making some sort of groups? No, she's not doing any sort of groups. That means that this can be clustered, this cannot be stratified, just because we don't have groups to start with. So is it convenience or is it systematic? So she is selecting 25 students from her class. That's people that is very accessible to her. So that looks more like convenience sampling. It cannot be systematic because she's not creating a system out of a list whatsoever. So this is convenience. People that is very available to her. She doesn't have to go outside of her classroom to get her sample. That is convenience. And that is pretty much all we have. I hope that this video it's helpful for you understanding the different types of sampling. Again, there are many more, but at least if this 5 makes sense to you, then we are good.